I very recently published a podcast about the Sedona RNAV Runway 3 approach and the missed approach. I've learned that I made some incorrect statements about the visual descent point, and I'd like to correct my errors. Now, I figure at this point, you guys know who I am, so I'm going to skip the intro. And this is a quick podcast, so I skipped the green room makeup section before recording just to get it out the door a little bit faster. Now, I've been flying IFR since 1978. I've always used Jeppson approach charts, except when I had to study NOS charts enough to pass the IFR written exam. So I thought that I knew Jeps pretty well. But recently, I was schooled about how the profile view is displayed on a Jep approach plate. In the Sedona video, I stated that the depicted 3-degree glide path from Barmy, the final approach fix, stopped at LOM, the missed approach point. I said it would have you at 50 feet AGL above ground level at LOM, so then you would have to shallow out your rate of descent to join the 3-degree PAPI. And you might even fly into the ground if you simply continued to fly blindly down. Now, when I looked at the approach plate while writing the script for the video, it seemed obvious to me that the depicted 3-degree line stopped at LOM and not at the end of the runway. I was wrong. One Copa-Forum participant took the time to investigate what's actually going on with the jet plates. He came to the conclusion that the Jeppson profile view presentation is not always drawn to scale. And that lit a fire under me to learn some more. I first looked up the Jeppson definition of visual descent point, and this is from the introduction. Visual descent point, VDP, a defined point on the final approach course of a non-precision, straight-in approach procedure from which normal descent from the NDA to the runway touchdown point may be commenced, provided the approach threshold of that runway or approach lights or other markings identifiable with the approach end of that runway are clearly visible to the pilot. Okay, this now makes it clear to me that even though the profile view looks like the 3-degree approach slope through the VDP stops at LOM, it actually stops at the normal 50-foot AGL height over the end of the runway. In other words, this is a normal VDP construction. Contrary to what I said in the video, you are not well below the PAPI. So I erred by assuming the profile view was to scale. So I was a bit confused and I dug deeper. I searched the Jeppson introduction for the phrase to scale, and I found 2 hits. The first said that the airport plan view is a to scale graphical depiction. The second said this about the approach plan view. The plan view is a graphical to scale depiction of the approach procedure. Now, there were graphical examples of charts that had not to scale in the approach plan view to let their user know when something is not to the correct scale. And that's common for fixes that may be a long way from the others. You know, the distance looks shorter than it actually is to get it to fit on the plate. So not to scale is noted. But there's no mention in the introduction that the approach profile view was to scale or was not to scale. But it does appear that the Sedona Jeppson chart vertical profile is not to scale. Now, here's how Garmin depicts the vertical profile on its smart chart. And this is courtesy of my Copa friend. I have never seen nor have I used a Garmin smart chart. Garmin clearly depicts the 3-degree slope from Barmy that passes through the VDP 2.9 miles from the end of the runway, and it terminates 45 feet AGL over the end of the runway. So clearly the Garmin profile depiction is to scale and is superior to the Jep depiction, I think, at least in this case. Now, I'm glad to know that at least following the 3-degree glide path from Barmy will not dump you off at 50 feet AGL at the missed approach point. Okay. Another Copa participant, who is an admitted math nerd, discussed how to calculate the turn radius for a given airspeed and bank angle. Now, if you really want to know, here's the formula. But for those of you who, like me, scored very poorly on the math SAT exam, you can go here to use an online calculator. Here's the turn radius for a true airspeed of 100 knots and a bank angle of 25 degrees. Now, I chose 25 degrees as that's what most flight directors use for bank angle commands. 100 knots true airspeed is a nice round number. That's pretty close to the true airspeed you'd be at if you're at 92 knots indicated at 6,000 MSL on the missed approach. It shows the turn radius is 1,897 feet. Now that converts to 0.31 nautical miles, and that's actually a shorter turn radius than I would have guessed. So with this new knowledge, you can disregard my comments about the VDPs in the main body of the podcast and also in the takeaways at the end of the video. I'm David Weeks, and thanks for watching this edition of Real World SF-50 Flying.